notes on mole conversions. Remember, we've already talked about what a mole is, and you've watched my video on that, and maybe you watched Tyler DeWitt's video that gives you a little bit more detail. And so here you're going to have to pause this video so that you can take notes as we go. First, to review what a mole is a chemist's way of determining or measuring the amount of a substance, so how much of it you have. And we learned two new conversion factors last time. Remember, the first one is the fact that you got 1 mole, or if you have 1 mole of something, you have 6.02 times 10 to the 23rd representative particles. Hopefully you remember what those particles could be. Remember, they could be atoms, or they could be molecules, or they could be ions. This is a conversion factor. So there are two ways to write it. You could write it with the mole on top and the 6.02 on the bottom, or you could put the 6.02 times 10 to the 23rd on top and the 1 mole on the bottom, depending on your dimensional analysis and what units you want to cancel. The other conversion factor we learned, I didn't really talk about it as a conversion factor, but it's the fact that 1 mole is equal to the molar mass in grams. You have to use the periodic table and add up your masses to figure this out. I've got my periodic table here. The first one, I want to know what the mass of 1 mole of copper is. So all I have to do is look at the periodic table and find copper. And remember, we round it to a whole number. So I'm going to round that up to 60. Where did it go? 63.5. So I'm going to round up to 64 grams. If I have water, remember water is H2O. So if I have to look at the hydrogen first, hydrogen's mass is 1 over here, and oxygen's mass is 15.9, so I'll round it up to 16. So I'll do, hopefully I need a calculator for that. I'll do 2 hydrogens, 1 plus 1, plus the 18, or plus the 16 for oxygen gives me 18 grams. And then I threw this one in here to remind you about your 7 diatomic molecules, your magic 7, or as I talk about them, your Hunkelbriefs. Remember, these always have the little 2 after them because they're always diatomic molecules. So with hydrogen gas is going to be H2. So instead of just 1 gram, it's going to be 2 because we have 2 of them. All right, now we're going to put that all together and we're going to do some practice problems with our dimensional analysis. Remember, your first step is that you take the number that they give you and you put it over 1. I'll do my 9.45 moles, and I should really have this in there too. You want to have your label in there. That's going to go on top. I'm going to use my underline to show my fraction there. And then on the bottom, get 1, put it over 1. Okay, and then on the second one, remember the shortcut is that you look at which units are on the top. I've got moles on top, so I will need moles on the bottom here before I even look at what I'm trying to figure out. I'm going to put moles of that thing on the bottom. And then in the problem, they've asked me to go to grams. I'm at moles, and I'm going to go to grams. So if you look back up here, the second conversion factor is at moles, and it goes to grams. So that means all I have to do is look these up on the periodic table and figure out their mass. All right, if you look at the periodic table, nitrogen is 14. So I will do 14 times 2 And then oxygen is 16, so I'll do 16. Well, it's 15.9, but we're just rounding into whole numbers. So I'll do 16 times 3. And then add that up on my calculator over here. So that's 48 plus. And that's it. If you just have 1 mole. For now, moles, the number by moles will always be 1. Eventually, when we start doing stoichiometry, that will change. But for now, moles is always 1. All right, so you plug that in. Remember, these are both on top. They're both the numerator, so you're just going to multiply. So I'll take, I already have my 76 in there, times, I think it was 9.45. Hopefully. All right, that's what I got. But first, before I go to the next one, I want to look at sig figs. This number only has 3 sig figs, and we're not counting the conversion factors. So I only want 3 sig figs here, which means I have to get rid of that too. Round it to 718. Remember, we could, if I was doing this on paper, I would show my units canceling. Like my moles have canceled because when I divide by that unit, that goes away. So I end up with grams at the end. All right, with my second one here, I'm calculating the number of moles and I'm starting with grams. So this is the opposite of the one that I just did. You do have to remember that oxygen is one of these Hankel-Griffs here, one of the 7 diatomic molecules. So it's going to be O2. So I'm taking the number that they give me, and then I'll put it over 1. Okay, and now I've got grams on top, which means I need grams on the bottom. So it's the same thing as this conversion factor, except I'm just flipping it around, and I'll have to make it specific for oxygen. Whoops, wrong button. O2, that's what I was trying to do. And because it's O2, you'll have to do 2 oxygens. So you look at the periodic table, remember it was 16, and then 16 times 2. And then up on top, that's 1 mole. All right, so now when I plug that in my calculator, since my 32 is on the bottom, I have to divide. So I'll do my 75 divided by 32. Can't do that one in my head. .34. Let's look at sig figs. I just dropped the E off moles. That's the abbreviation. It's not really that much shorter, but so I did 3 sig figs because 75.0 is the 3 sig figs. All right, here's a different one. We've got, they're asking for molecules and they're giving us moles. I'm just going to copy and paste here. So copy and paste that in. It's going to be over 1. Sulfur dioxide, we didn't really learn how to name those, but I think you could probably figure that out. That's SO2. So I'll stick that on there too. For my second fraction, I know I have to have moles of that SO2 in the bottom. And for now, you know that moles is always 1. So I will just go ahead and stick a 1 in front of there, maybe. There we go. And I'm trying to get to molecules. So this time, on the last two, we looked at the periodic table and we looked for grams. But this one, we're going to molecules. So that means I use this big number up here, Avogadro's number, 6.02 times 10 to the 23rd. And the particles are molecules. Okay, remember, you know how to type this in your calculator already. You're going to use your EE button. Unless you don't have one, then you're just going to have a lot of parentheses. Okay, so I found a calculator with an EE button here. I've got 2.57. And then EE 5. And then times, because the 6.02 times 10 to the 23rd is up on top, I'm going to multiply between these two. And then remember, instead of times 10, I'm hitting EE. That takes the place of the times and the 10. And then I'm putting in 23. Okay, so with this calculator, I've got 1.547 times 10 to the 29th. Oh, it doesn't want to do exponent. I'll do 29th. All right, and then I want to look back at sig figs. I've got 4 sig figs right now, but this number only has 3 sig figs. So I'm going to make round my 4 up to a 5 and then get rid of my 7. All right, this one is very similar. They're asking for atoms. Atoms and molecules are both representative particles. Right, they are these things we wrote down right here. So with atoms, I'm still using that number. This number is for atoms, molecules, or ions, any kind of representative particle. So I'm going to take the number that they give me, put it over 1. Copper. Okay, so I know I'm going to have 1 mole on the bottom, and I know that because I have moles on top, and I have to get my moles to cancel. And then this time, again, they're not asking me for mass. They're asking me for atoms. So that's my 6.02 times 10. And I'll use the millicarat key to the 23rd. Okay, so then just like the last one, I'm going to plug that in. I'm going to multiply